Essay 3.8, solving trigonometric equation. So the purpose of solving trigonometric equation is to find the solutions. So if you look at a sine curve here, you may notice that it passes through the vertical line test. However, it fails the horizontal line test, right? So what this tells us is that when you do sine of an angle, you get one answer only. However, when you do inverse sine of a value to find the missing angle, you get multiple answers. So in fact, infinite number of answers and or angles are possible. So in theory, you could describe infinite answers. So for example, let's say you have a tangent graph like this, okay? So when you have a tangent graph, you know that it repeats every pi. It repeats at every pi, right? So you could have the tangent x equals to 1. So when you have an equation tangent x equals to 1, you know that you can find the x value, the angle, by using the formula pi over 4 plus k pi, where k value is all positive integer. So it is far more likely that they will give you an interval in which your like angles must fall in between. So when you do questions like this, it can carry a considering many angles. So you have to discard unwanted ones at the very end. Okay. So let's do an example here. So example number 1, we have to solve the 2 sine x equals to 1. Okay, and the angle x is between 0 and 2 pi. So we have 2 sine x equals 1. This is same as sine x equals to 1 over 2. Okay, we know that the sine x has the positive value when it is located in quadrant 1 and quadrant 2. Okay, then using the unit circle, we know that when the angle is pi over 6, we know that it will have the sine value of 1 over 2, right? So our first answer is pi over 6, and this is our reference angle. And we know that our next answer is located in the second quadrant. So we're going to use the reduction formula, pi minus theta. So we know that pi minus theta, or the pi over 6, is same as 5 pi over 6. So you got two angles now, 5 pi over 6. And this is, and then the next angle will probably going to be 2 pi minus pi over 6, right? And it's going to be 11 pi over 6. So this is after 2 pi, so this is not the answer. So you can say that these two are your answers. Okay? And example 2, we need to solve 2 cos x equals 2 sine 2x, where x value is between 0 and 180 degree. So we have two variables, sine and the cosine. So we're going to get rid of one of them using the double angle identity. So double angle identity is when you sine 2x, this is same as 2 times sine x times cosine x, right? That's double angle identity, and it's in your formula booklet. So using this, we can say that 2 cosine x is same as 2 times sine 2x is same as 2 times sine x times cosine x. So we can replace it, right? And this is same as 2 cos x equals 4 sine x times cosine x. And when I move the right hand side, what's in the right hand side to the left hand side, this is same as this, then I can factor this as 2 cos x 1 minus 2 sine x, okay, and equals 0. Then this is same as cos x, 2 cos x equals 0, or 1 minus 2 sine sine x equals 0, which is same as cos x equals 0, or sine x equals 1 minus 2. Once you reach this point, you know that cos x equals 0 happens at the first quadrant, which is 90 degree, right? And also we get the positive cosine in the second quadrant, which can give us the third quadrant, which can give us the 270 degree. So it is definitely greater than 180. So the 270 is not the correct answer, right? And when to have a sine x equals to 1 over 2, we know that sine x has the positive values in the first and the second quadrant. So when in the first quadrant, pi over 6 or 30 degree has the 1 over 2 as each value. And in the second quadrant, we know that when you do 180 minus 30, so I'm using reduction formula, we know that it's 100 equal to 150. So it is less than 180 degree. So these two are the also answers. So our answers are 150, 30 degree, and the 90 degree. Okay, then let's do number 3, example number 3. Here we need to solve the sine x equals square root 3 times cosine x, and then our x value is between the pi and the negative pi. So there are two ways of solving this question. The first method that we can use is using the tangent theta equals sine theta over cosine theta, or just using the Pythagorean's identity. So let's do this question in the new page. So we need to solve sine x equals to square root 3 times cosine x. So I'm going to use the first method first, using the tangent. So we know the tangent theta is same as sine theta over cosine theta, right? So using this concept, we can say that sine x is equal to square root 3 times cosine x, which is same as sine x divided by cosine x, which is equal to tangent x, is equal to square root 3. Okay, then on a unit circle, we know that, so let's say we have a unit circle, okay, and we have our angles. We know that there's an angle 30 degree, right? 45 degree and 60 degree. And we also know the values of the cosine and the sines in this with these angles, right? They are actually look like this. And we know that the first one is the cos, right? And the second one is sine. And we know the tangent theta is same as sine theta over cosine. Then using this rule, we know that when the angle is 60 degree, we actually have square root 3 over 2 over 1 over 2, which is sine theta over cosine theta, which will give us 2 square root 3 over 2 that simplifies into the square root 3. So we know that when we have, or when the x value is equal to 60 degree, or pi over 3, we know that the tangent x is equal to square root 3, right? Then using this information, we can say that the tangent theta is actually positive when we have our values in the first and then the third quadrant, right? Then we can say that, okay, our first quadrant, when you have tangent in the first quadrant, our x value is equal to pi over 3. Okay, then using this as our reference angle, we can find our values in the third quadrant using the deduction formula. Okay, so deduction formula that we're going to use with this question is tangent pi plus theta is always equal to positive tangent theta value. Okay, so we do pi plus pi over 3, which can give us 4 pi over 3. Okay, and however, we know that our angle is also between the negative pi and then the x value, right? Or the 0 value. So we have to find this negative side. So in order to do that, since we know that the tangent is rotating every single pi, we can also do negative pi plus theta to find our negative tangent theta value, right? So we need to do negative pi plus theta to find our values on the negative side. Okay, so negative pi plus pi over 3 will give us negative 2 pi over 3. Okay, then you can see that we actually have 3 possible answers, right? They are pi over 3, 4 pi over 3, and negative 2 pi over 3. Okay, and you can say right away the 4 pi over 3 is not the correct answer because the answer needs to be between the pi and the negative pi. So our final answer is pi over 3, negative 2 pi over 3. Okay, so let's try to solve this question using Pythagorean's identity. So we know that Pythagorean's identity is same as cosine square x plus sine square x equals to 1. And we know that this question has 2 variables. So I'm going to get rid of one of the variables by manipulating the Pythagorean's identity. So here I have a cosine square x plus sine square x equals to 1. So I'm going to say cosine square x is same as 1 minus sine square x, which is same as cosine x equals to square root 1 minus sine square x. So using this information, I'm going to substitute cosine x with the square root 1 minus sine square x. So I have sine x equals to square root 3 times square root 1 minus sine square x, right? Then squaring the both sides will give me sine square x equals to 3 times 1 minus sine square x, and simplifying this will give me 3 minus 3 sine square x. Moving this to the other side is same as sine square x plus 3 sine square x equals 3. So it is 4 times sine square x equals 3. Sine square x is same as 3 over 4, and sine x is same as square root plus minus square root 3 over 2, because I can square root both sides, right? And this means sine x can be square root 3 over 2, or sine x can be negative square root 3 over 2. Okay, to have the sine as a positive value, we need to have it in first and the second quadrant. To have the sine as negative value, we need to have it in third and the fourth quadrant, right? So if the sine x is equal to square root 3 over 2 in the first quadrant, we have angle pi over 3, right? And this is our reference angle. Then using the reduction formula, we know that pi minus theta can give us the positive sine theta value. So this is pi minus pi over 3. Then this is same as 2 pi over 3. So this is our second value. Okay. Then also we know that we need to find the negative side of it, right? Because the x value is actually between the negative pi and the pi. So in order to do that, we're going to subtract the reference angle from the pi. Okay, so we're going to go negative pi minus pi over 3. Then this will give us the negative 4 pi over 3, which is not the correct answer, so we don't have to worry about it, right? Then let's look at the sine x equals to negative square root 3 over 2. Okay, so on the third quadrant, we know that it will give us the 4 pi over 3 as our reference angle, right? Then on the fourth quadrant, which is the quadrant that will have a negative sine x value again, using the reference angle, it's going to be 2 pi minus theta. So using this reduction formula, we know that it's 2 pi minus 4 pi over 3, which is same as 2 pi over 3. So this is again our another angles. So remember, we need to still find all the solutions first and have to reduce it, right? After that, we need to find that the angle in the negative side, because this is between the negative pi and the pi, right? So we're going to do negative 2 pi plus theta. So negative 2 pi plus 4 pi over 3 will give us the negative 2 pi over 3. Okay, so this is our last angle. Then we now have pi over 3, 2 pi over 3, 2 pi over 3, and negative 2 pi over 3 as our possible answers, right? Possible answers. Okay, and we know that 4 pi over 3 is not the answer because it's over pi already. So let's check whether this is whether this is possible, or to figure out which one is possible or correct answer. Okay, to figure out which one is correct answer, we need to put these possible angles like pi over 3, 2 pi over 3, and then the negative 2 pi over 3 into the original equation. Sine x equals to square root 3 times cosine x. Okay. Then we know that sine pi over 3 is same as square root 3 over 2, right? And square root 3 times cosine pi over 3 is same as 1 over 2, so they're equal to each other. So this is correct angle that we can use. Then when you think about 2 pi over 3, sine 2 pi over 3 will give us the square root 3 over 2. And square root 3 and the cosine 2 pi over 3 will give us the negative 1 over 2. So they're not equal to each other. So 2 pi over 3 is not the correct answer. Okay, then when the x value is equal to negative 2 pi over 3, the sine negative 2 pi over 3 will give us the negative square root 3 over 2. And we have square root 3 and times cosine negative 2 pi over 3 will give us the negative 1 over 2. So the answer is correct, right? So there are two answers. They are pi over 3 and then 2 pi over 3.